Alrighty, so let's go and get started here. I'm going to record a bunch of these videos, and the goal of these videos is basically going to be to provide you the same kind of instruction you would get if you were in a classroom environment and you took a programming class. I'm going to record these using my old tablet computer, and this is my way of avoiding having to make a whole bunch of slides. The big two downsides of this are that one, my tablet computer is super old and still runs Vista, and then the second downside is that you're going to have to try to read my crappy handwriting. But as long as you can put up with me using a really old computer, and as long as you can decipher my chicken scratch, hopefully you'll be able to go from knowing nothing about programming to being at least halfway decent by the end of all of these videos. Alright, and I think the first one I'm going to start off with is just a basic introduction to programming languages. I think this kind of gets skipped a lot. People just dive into the programming, and so I think it'd be valuable to just start off and see what's actually going on when we're doing this. Alright, so programming languages. There are a lot of them. A couple popular examples, there's C, C++, Java, there's Python, there's Ruby. I could go on for a long time just listing off programming languages. There's hundreds of them, and more of them are invented every day. But all of these are known as high-level languages. All right. They all do slightly different things. They all have slightly different syntaxes, but the key is that all of them together do the same thing, and that is that they control the computer. Alright, when you learn how to program using any one of these languages, for the first time, you are no longer running someone else's tool on the computer. You are actually directly telling the computer what it is that you want to be able to do. And that is a very powerful thing. It basically transforms the computer into a tool that you can use to do anything you want. So anything that you can imagine, if you have the know-how with these programming languages, you can make the computer do that. And so let's take a look at what that actually means and how these programming languages do it. All right. So to start off with, you have a computer over here. All right, and it's got a keyboard. All right, and the computer is running a thing called assembly code. All right, and assembly is the actual instructions that a computer CPU is running on the inside. It doesn't matter if it's your phone, it doesn't matter if it's your tablet, the computer that you are watching this video on right now, all of these machines are all running assembly instructions. It is a small set of instructions, and it just one after another just rips through them as fast as it can go. And this is the only thing a computer can actually understand. A computer cannot understand anything else other than assembly. All right, most people are very familiar with assembly. On Windows, it normally comes in a .exe extension. There are a couple others, but that's the one people see. The problem with assembly is that, one, it's hard to read, and two, it's even harder to write. And this makes us sad. We do not want to have programming a computer be difficult. And if we had to go and write assembly by hand, which you can do, it is very difficult, very time-consuming, and it is not a lot of fun. All right, and so because of this problem, there were a bunch of smart people out there, and they invented a thing called a compiler. And what a compiler is a program that you can install on your machine. It basically takes a whole bunch of code files, and with these code files, it takes them in, it does some black magic, and with your code files, it translates it and converts it directly into assembly code that the machine can run. All right, The compiler is the key to making programming computers easier. And it actually is virtually all of the code that is running on your machine right now, including the operating system, went through this process where it started out as code files, went into a compiler, and was translated into assembly that could be directly run on the computer. Everything from the web browser to the video player that you're possibly watching this on, all the way down to the operating system. If you know how to do this, and if you have a compiler, you can literally write a new operating system for your computer. And there are people out there that have done it, and they usually go mostly crazy. But it is possible. You can completely rewrite a new operating system for your computer if you have the know-how and you have a compiler. All right. So to start off with, we're going to focus in on C++. C++ I think is a powerful language. It's not that I think it is, I know it is. But I think it's kind of a good balance of being very low level, but also having a lot of the higher level constructs that a lot of the newer languages have. It's object oriented. But it still is very close to what assembly gives you. And so we're going to focus in on that one. If you're trying to learn C, it's really not all that big of a jump because C is a subset of C++. Virtually every C program out there can run using a C++ compiler. All right, so let's take a look at the C++ compiler. Closer look at C++'s compiler. All right, so to start off with, you have code files. All right, in C++, they end with a .cpp extension, stands for C++. All right. And the most important thing to recognize about these code files is that they are just text. The fact that they are a .cpp extension does not mean that there's anything fancy about them. Code that you write is just text. You can open it up in Notepad. You can change it in Notepad. There are people out there who do entire programming just using straight up text editors and a compiler. All it is text files. And these text files are fed into the first stage, which is the compiler. All right, and the compiler does the first pass. It checks your syntax. And all that is it just, the C++ can be thought of as a whole bunch of rules for how to control the machine, and if you break one of those rules, you're going to get an error. The compiler will say that there is a syntax error, and it will complain. It will tell you the line of your syntax error, and you will have to go and fix it. There are very strict rules on how you have to format all of your statements, and the first phase of the compiler is to make sure that it can understand what it is you typed in according to the rules that it has set out. All right, and once it's checked your syntax and read through everything, it's going to convert your code into assembly for the most part. Converts your code mostly into assembly. All right, and the output of the compiler is a bunch of .o files. I believe on Windows they're .obj. It doesn't matter, it all comes out to the same thing. But these are, for every .cpp file you have, you're going to get one .o file out. And that is just a mostly compiled version of each one of those files. All right, and those .o files are then sent into the second pass of compiling, which is called the linker. And what the linker is going to do is it's going to take all of your code and all of the third-party libraries that you might have used, and combines them all into one executable. All right. And what I mean when I say third-party code, when you're writing code, it is exceedingly rare that you write every single line of code. It is a waste. It's reinventing the wheel. There are a lot of things out there called libraries, which is just code other people have written to make common things easier. And the linker is what takes other people's code, combines it with your code, and takes all of it and packages it into one executable that can run on any machine that the compiler was designed for. All right. I point out these two steps because you're going to get, as you do this, two types of errors. The most common one you're going to get are these compiler errors. And what that means is that there's a problem with your syntax. You have done something wrong that the compiler cannot understand. But you're also going to get linker errors. And linker errors tend to be a little bit more difficult because your code is technically fine, but there was something about trying to package it all together that didn't work. Okay, and linker errors tend to be a little bit more difficult to solve, but once you've seen a bunch of them, they're no more difficult than just regular compiler errors. All right, and when you get this, when you're done, your exe can be anything. It could be the next Facebook. It could be the next Minecraft. Or what is exceptionally more likely is that it could be a steaming pile of crap, because the truth is that writing code that is even close to stable enough for others to use takes a lot of time and energy. You're going to find that out as you do this. Writing good code takes a lot of iterations. You have to do it over. You have to go over it again and again and again, fix problems, find problems that you didn't think were there the first time, fix them, and then after you've been doing this a long time, you can maybe start thinking about the possibility of showing it to someone else. All right, so how do we develop code? How we develop code. We develop code in something that is called an IDE. And you're going to hear this acronym a lot. An IDE is an integrated development environment, or the most complicated text editor you will ever use. All right. It is important to realize that these IDEs that we use are really nothing more than just really, really, really advanced text editors. Okay. A couple examples of them. There's Visual Studio, which we're going to use. But then if you're writing code on the Mac, there's Xcode. If you're writing Java, there's Eclipse. If you're writing Java, there's also IntelliJ. There's one called PyCharm. And the list, again, for these just goes on and on and on. There are hundreds of them. Some of them are free. Some of them cost money. Some of them are kind of half, where there's a free version and a professional version. But they all basically do the same thing. Because at the end of the day, what this IDE does, when you open it up, what it's going to look like is it's going to have kind of two sections. On the left, it's going to have a bunch of files. All right, and the right, it's going to have your code. And your code is just going to be a bunch of text. Okay, and you're going to use this to edit your code, write it, get it to what you want it to be. And then the IDE, when you tell it to, is going to take your code and it's going to kind of pass it into the compiler for you. All right, and it's going to do all the settings, all of the stuff that it takes to properly run a compiler. It's going to do that for you, and it's going to output your executable. And then once you have your executable, it's then going to run it for you. And then, assuming that your executable actually runs the way that you wanted it to, it's probably going to generate some output. And the IDE is going to take that output and display it for you, all in one convenient package. All right, this is what IDEs do for you. They are just an all-in-one package that allows you to write your code, compile it, and run it, all without having to dance around and deal with all the different moving parts. They are very useful. They make writing code a lot easier. And then most of them include some sort of debugger, which makes finding out what went wrong with your code a lot easier as well. All right, so let's talk about a few things about compilers, and these are important. So to start off with, first, compilers are strict. I cannot tell you how many programming classes I have been in where there have been people who have been saying, I know what I want to do, why can't the compiler just do it for me? Okay, and that's not the way it works. A compiler cannot guess what you are trying to say any more than Microsoft Word can guess what novel you are trying to write. A compiler is just there to take the code you wrote and convert it into assembly for you. It is a garbage in, garbage out kind of thing. If you write bad code, the compiler will generate a bad executable. It cannot guess what you were trying to do. It cannot assume what you were trying to do. You have to be they are very strict, and you have to play by the compiler's rules. And you will see this as you see errors of things that you think that it should have been able to guess, but the answer is no. The compiler is strict and will demand that you conform to it. All right, the second thing, compilers are consistent. The reason I bring this one up, there was a study done a while ago where they tried to predict how good of a programmer someone could be after they have taken a programming class. And what they found was that those who acknowledge that computers are consistent and that the syntax a compiler accepts will be consistent across all applications, they were the ones who did the best. All right? So what that means is as you're learning how to program, if you see an equal sign in one instance, it will almost certainly do the exact same thing if you use that equal sign somewhere else in the code. All right? The meaning of syntax in a compiler does not change depending on where you are. All right? The way that these things work is you're going to have to learn a bunch of different language constructs, and you're going to have to take these and build them together. But know that every time you learn one of these language constructs, it's going to work the same way no matter where you put it. Compilers are consistent. If given the same input on the same code, they will always generate the same output every time. And if that is not true, it almost certainly is a problem with your understanding of the compiler. It's not that the compiler is inconsistent. All right? Which kind of leads us into the third one, and that is that compilers, and boy, people complain about this one, compilers are never wrong. All right? Again, I cannot tell you how many beginning programming classes I've been in where people swore that the compiler was wrong, okay? But it's like arguing with a woman. You always end up at the end realizing that you were the one that was wrong. The compiler is always right. This is also important because you are going to be staring at code, and you are going to be staring at a compiler error, and every single time that you see that, you are going to swear that the program is right and that the compiler is wrong and that there is not an error, but then eventually you're going to realize, no, the compiler is right. All right. This is not to say that it is impossible for a compiler to be wrong. A compiler is a program, so it can always have a bug in it. But the point is that I've been dealing with compilers for 16 years, and I have yet to find an example of the compiler being wrong. It is always your understanding of the compiler that is wrong. So if the compiler is saying something is wrong, it is an opportunity for you to learn more about the language and learn more about what is going on. All right? All three of those, at some point as you're doing these, you will swear that I was wrong as I say these three, but I promise you all three of these statements are true. All right, so let's see if you've been paying attention. I'm just going to do one question here. Question one. do you need an IDE, Integrated Development Environment, to program? Okay, think about that for a second. Pause the video if you have to. Come up with an answer. And I'm hoping that the answer you came up with is no. You do not need an IDE to program. What you do need is a compiler. A compiler is the key to programming. All right. This happens a lot in programming classes where they will show you how to install Visual Studio, and then people will assume that if they want to program a computer, they need something like Visual Studio, and that is not true. What you need is a compiler. The compiler is actually something that is separate from Visual Studio, and Visual Studio just orchestrates with the compiler and runs it for you, which is super convenient. It makes everything a lot easier, but it is the compiler is the key to programming, not the IDE. All right, and I lied. I'm going to go ahead and do a second question too. There we go. So, question number 2. Can you compile, or can you program any language with any compiler? All right, stop and think about that one for a second. I think this one's kind of a lowball. The answer is no. Okay, compilers are language specific. There are some compilers out there that can compile in more than one language, but those compilers are specifically designed to say we can accept more than one language. In general, anytime that you are programming, if you are going to program in a new language, the first thing you have to do is you have to download and install the compiler for that language. All right. Conveniently enough for you, as you go forward and you install Visual Studio, it will install the compiler for you as a part of the install on that. All right. So just a quick review now. Programming languages are about controlling the computer at its lowest level. Compilers are key. All right. You can kind of think of it as though everything you have ever done with a computer up until this point has been like being in a little nursery where there were these walls that you were not allowed to go into. Compilers are the key to the kingdom. Those are the keys to the kingdom where you can go, you can leave that little safe space, and you can go and make a computer do anything. All right, and finally, IDEs, integrated. This is the last time I will actually write this out as well. IDEs make programming easier. So we use them. But they are not required. Alrighty, so I think that just about covers an introduction of how programming languages work. We just kind of went over some high-level languages, just talked about how computers run assembly and how high-level languages are related to assembly, looked at C++'s compiler, the steps that it goes through, talked about what IDEs are and what they do for us, and then had these 3 statements, which you will be cursing me for being right about these 3. All right, in the next program, we're going to actually launch up Visual Studio, take a look at what an IDE does, make our first program, and just go through the process of building your first programming language. So